All right, today what we're going to take a look at is using the Desmos graphing calculator in order to do some problems that would otherwise not be especially enjoyable to do by hand. Or alternately, it's another method that you can use to graph things, hence the name graphing calculator. And we are going to first go ahead and take a look at how we enter tables into it. So first you go to desmos.com and you click on the graphing calculator, and you should get a screen that looks just like this. So the first thing we need to be able to do is to enter a table. So what I'm going to do is I'm going to go up to this plus in the upper left-hand corner, and I'm going to go down to table naturally. And from here, we're able to enter our X and Y values for the data. Now, I have some values already prepared that I'm going to plug in here. And we're going to do some interpretation. On a normal problem like this, you might be given it like a table on a test, for example, where you could plug it in, or on a homework assignment that you could then plug in the data. I have it up on another screen, so bear with me for a moment while I enter it. As you can see here, I'm entering the number and hitting enter, and it takes me to the next line. And since this one follows a very nice pattern, we're able to very quickly fill in the rest of them just by hitting enter. You can also just always manually enter every single number. So those are the X values. Our Y values don't follow quite the same pattern. As you can see here, the point -1, -3 has appeared on our graph right there. You can click on it and it will tell you what the point is. And the point 1, -1 has also appeared. Now, we have our points graphed, and we're going to go ahead and take a look at what the approximate shape of this graph looks like to see if we can predict what type of function it is. So the ones that we've seen so far have been our absolute value, that's the V shape, our straight lines, I think you can imagine, and our more U-shaped parabolas. So if we zoom out a little bit, we can see these 7 points, and they don't line up perfectly neatly. But if you look at this, it doesn't really look like a V shape, and it's certainly not a line. So based upon what we know so far, we would have to conclude that this is probably a parabola of some point. For example, if we just put down our parent function, y is equal to x squared, it opens up. This one obviously doesn't open up, so let's make it a -x squared. And as you can see, while it doesn't exactly line up on the dots because the function is not identical, it does look like it has the same approximate shape. And in fact, the actual equation for this function is -x squared plus x minus 1. And as you can see here, all the dots line up right on the parabola. So you will be expected to be able to look at a series of points, plot them, and then ask yourself, what type of equation does this represent? For lines, I think that'll be pretty obvious. For the absolute value versus quadratic functions, you'll have to look a little bit more carefully. But that's one thing we can do on our Desmos graphing calculator. The other thing we can do is we can run what is known as a linear regression. Now, the purpose of linear regression is to take some data which is related to each other and then describe a line which best fits the data. And this line of fit, or line of best fit, is what's known as the least squares regression line. Now, knowing all of these things isn't that important because we're not actually going to calculate this by hand. We're going to use Desmos to do it because calculating it by hand is a pain. So we're going to go ahead and start anew, and we're going to enter a new table. And again, I have some values prepared for this one. We have X values of 19, 24, 26, and 29. And our Y values are 45, 46, 47, and 51. And what we're going to do is we're going to run a regression using these 4 data points. Now, there is a particular equation that we need to type in that will tell us what our regression line is. It is y1. You literally just need to put in y1 as an enter, hit the y key and then the 1 key, and it will do y sub 1, which is what we're looking for. And then we don't have the equal sign. We actually have the tilde, which is shift plus the key right to the left of 1. Then we have our M, That's our good old slope, x1 plus b. So this looks just like our y is equal to mx plus b, except we use y1, x1, and the tilde in order to tell Desmos what we're looking for here. And what this finds for us is we have these series of data. R squared and R represent how accurately the line represents the data. And the closer they are to 1, the better. So 0.79 for your R squared isn't bad. The parameters M and B, these tell you what your actual slope and y-intercepts are for this particular graph. So if we go ahead and we look up here, this red line is supposed to minimize the differences or minimize how far each of the points is away from the line. And it looks like it did an okay job here. And just to prove to you that this line uses the slope and the b value that are present there, if you were to actually type in y is equal to 0.556604x plus 33.6132, as you can see, the lines overlap with each other. 632. Now, they probably don't exactly overlap because I rounded a little bit, but we would look at this and say this is close enough. So that is the purpose of linear regression. It takes data which is not perfectly linear and then spits out the line which best represents that data. And that concludes our use of the Desmos graphing calculator for this chapter. You will be expected to be able to enter tables as we did here, as well as find the line of best fit using the linear regression tool that is present here on the test.